back to another episode of Team Kim. But remember, today we have no silliness, no horseplay. Our lab today is finding the molar mass of a volatile liquid. Enjoy! The objective of this experiment is to find the molecular weight of an unknown gas, then find the identity of the gas. Pre-lab question 1 is, what is the equation used to find the molecular weight of a gas? The equation is meow equals dirt over P. Pre-lab question 2 is, read through the lab procedures. For each part of the equation you wrote above, describe where you will gather the variable during the lab. Pre-lab question 3, create a data table to hold the data for this lab. Be sure to include space for 2 trials. Pre-lab question 4 is, if 2.51 grams of the vapor of a volatile liquid is able to fill a 498 milliliter flask at 100 degrees Celsius and 775 millimeters of mercury, what is the molecular weight of the liquid? What is the density of the vapor under these conditions? Pre-lab question 5 is, why is a vapor unlikely to behave as an ideal gas near the temperature at which the vapor would liquefy? Step 1. Weigh a dry, empty 250 milliliter flask with a foil cover to the nearest 10,000th gram. Step 2. Obtain an unknown liquid and record its identification number. We picked unknown number 1. Step 3. Add 5 milliliters of the liquid to the dry flask. Tightly cover the flask with the foil and punch a single small hole in the foil. Step 4. Heat the water in the beaker to boiling. When the water is boiling, adjust the temperature of the flame so that splashing water does not hurt you. Step 5. Submerge the flask into the boiling water so that the bottom of the flask is covered by the water. Clamp the neck of the flask. Step 6. The liquid in the flask will begin to evaporate and excess vapor may be observed escaping the hole in the foil. Step 7. After 2 or 3 minutes, all of the unknown liquid should be vaporized. Then remove the flask from the boiling water. Use the clamp on the neck of the flask to protect your hands. Step 8. Set the flask down, remove the clamp, and allow the flask to cool to room temperature. While the flask is cooling, measure and record the exact temperature of the boiling water in the beaker as well as the pressure in the lab. Step 9. When the flask has cooled completely, carefully dry the outside to remove any droplets of water. Then weigh the flask with the foil cover and condensed vapor to the nearest 10,000th gram. For step 10, we got a new beaker for the second trial. Step 11. Repeat steps 1 through 9. The densities of the 2 trials must be within 5%. Step 12. To find the volume of the flask, remove the foil and completely fill the flask with water. Pour the water into a 500 milliliter graduated cylinder and read the volume. Step 13. Calculate the molar mass of the liquid. We think that our unknown is octane because our molar mass is 104.7 grams per mole. Post-lab question 1. It was important that the flask be completely dry before the unknown liquid was added so that water present would not vaporize when the flask was heated. A typical single drop of liquid water has a volume of approximately 0.05 milliliters. Assuming the density of water is 1 gram per milliliter, how many moles of water are in 1 drop of liquid, and what volume would this amount of water occupy when vaporized at 100 degrees Celsius and 1 atmosphere? Post-lab question 2. Determine whether each of the following errors would make the final calculated value of the molecular mass too high, too low, or would cause no change. Explain your reasoning. A. All of the liquid did not vaporize. Post-lab question 2b. The temperature of the boiling water was 2 degrees Celsius above the temperature recorded. In conclusion, our errors were that we did not let the flask cool enough, so we had to do a third trial. For the third trial, we tried to dry a wet flask by waving it around. Then we heated the water off it and started waving it around again. At this point, Big Brain Tollett advised us to cool the flask by pouring water on the outside. By adding this tip to the procedure, you would get done faster, unlike us who are micro-brained. I hope you enjoyed our serious video. In the comments below, tell us what you would like to see next. Recently, we got 5 subscribers. Next time, let's get 10.
Oh my god, Lily!